A loss of cell-to-cell contact is one of the characteristics of the cancer cell. Epithelial to mesenchymal transition. This is a pathological process where polarized epithelial cells lose their epithelial characteristic and transform into mesenchymal cells. Mesenchymal cells are non-polar and migratory and invasive, in contrast to epithelial cells, which are polar, tightly packed, and form the lining of the organs. Normal cells that are cuboidal and stationary, bound to the extracellular matrix by integrin and other adhesion molecule, and bound to each other by cadherin and other cell-to-cell junction. There is a loss in that over time you have a gain of mesenchymal protein. Several are of study, such as N-cadherin and neurocadherin is increased in these cell types, and then we have a change or loss in integrin adhesion to the extracellular matrix. This causes the cell to be more stretched out and to function quite different than normal cells. This is a difference between the cancer cell or the malignant cell and the normal cell. These cells become more invasive and begin to invade or move into surrounding tissues. The first characters was replicative immortality, followed by genomic instability, and so genomic instability process produce a daughter cell with the mutation, and that cell give rise to other daughter cells, and then you end up with the hyperplastic lesions, which typically is the primary or the first lesion seen in several adenocarcinomas. And then you have cancer in situ that is accompanied by inflammation as well as the invasion of immune system and resistant to cell death, and then you get invasive cancer that is triggered by loss of cell-to-cell contact, cell ECM contacts, as well as increased and intrinsic factor within the cell that cause the cell to move from its origin space in the organ. Key steps during metastasis: the first step being invasion, breaking through the extracellular matrix or ECM, and this is local tissue invasion, as well as cells become more aggressive and more mobile and motile. They can gain cellular properties that allow them to break through the protective extracellular matrix. They break out of the extracellular matrix and go into the newly formed blood vessels, angiogenesis, and are able to get into the blood vessel more easily. Note that there is a difference between cell movement and invasion. Think of movement as walking across a room versus invasion is using elevator to go down to the first floor if you are on the 9th floor of building. So invasion push the severity of the cancer to a higher level. The next step is in metastasis, or key step in metastasis is a step called intravasation. Cancer cells intravasate into the blood vessel, usually by pushing their way through the vascular endothelial cells. This again ties us back to angiogenesis, and you can now appreciate the process of angiogenesis and how it can promote cancer cell to get into the bloodstream more easily, given that these blood vessels typically are poorly formed. The next step for cancer cell to be fit enough to survive in the human body is being able to survive during systemic circulation. So cancer cells must in a transverse venous system, and they have to be able to get to the heart, back out of the lung, back to the heart, and bend through the arterial system, where could go everywhere and wind up anywhere. Although sometimes a circulating tumor cells or CTC may just stop in the lung and never really enter the arterial system, This could develop lung metastasis during the transition through the circulation and must survive various sources of death and cellular stresses that a normal cell just simply would not be able to endure. And the last key step in metastasis is extravasation. When cells get out of lymphatic system and set up secondary tumor site in the distant organ, once a cancer cell can begin to grow a metastatic tumor in secondary site, this tumor follows many of the same hallmarks as previous tumor do, such as replicative immortality, resistant cell death, avoiding immune surveillance, alter metabolism, as well as other cellular features. The larger the secondary tumor become, the more problem it can cause. Cellular characteristic of cancer. The first one we covered was replicative immortality, which involve telomeres and telomerase. Telomeres are the sequences in the end of the chromosome, and telomerase is the enzyme which maintain this telomere. The second one was genome stability, which involved the production of daughter cells that breed genetic mutation, alteration and deletion, and these cells were able to continuously divide. The third hallmark we covered was evasion of the growth suppression, and the fourth, resistant cell death followed by sustained proliferation. And we covered how work together to allow tumor genesis. Emerging hallmark that we discussed were alter metabolism by the Warburg effect, where cancer cell can cause alternate sources of energy. They are able to avoid the immune destruction as well as use tumor promoting inflammation to their advantage. To induce movement, the cancer cells are able to induce angiogenesis as well as induction of invasion and metastasis. These are the 10 criteria of the cancer cell we speak about. This is all about the cell to cell loss of contact between cell and the cell, and the loss of the adhesion molecules which adheres cells, normal cells. And this one of the characteristic of the cancers among the other characteristics. Thank you.